Well, it's no small surprise that fingerprints are the most valuable of all of the evidence that you can collect from a crime scene. It doesn't just have practical application in a criminal investigation. We also use it in our day-to-day lives. You use fingerprints to identify yourself whenever you're trying to gain access to certain buildings that may be in accordance with your work or possibly even your home. We use fingerprints to identify ourselves when we need access to critical account information through banks or corporations. But when it comes to criminal investigations, the most basic of the evidence items that we can collect is what each individual person leaves at a crime scene. That's where our fingerprints come into play, our friction ridges. Whenever we touch something, as Locard's exchange principle asserts, we're going to leave evidence of our presence there. That means there's an exchange of information, an exchange of evidence. Fingerprints are going to take one of three different forms. They're going to be visible, meaning that we can see them with the naked eye. You might also hear this called patent prints. They're going to be impression prints, those that are left in the surface of whatever we come into contact with, such as you would find if you contacted a bar of soap, some silly putty, maybe candle wax. And then you also have latent prints, which are hidden to the naked eye. It doesn't mean they don't exist because we can't see them. It's just that we have to go through certain techniques in order to try to make those prints visible. When we go through this process of trying to determine what the value is of the prints we're trying to collect, it's going to make a difference in the collection technique that we used and then how we try to make those prints visible. Now, the basic materials we're going to be using for this demonstration today are going to be the ones that most of us have in our homes already, or you can easily find at a garage sale. We're going to be using a basic fishing tank. I've got a piece of foam that I got. It's foam insulation that I've cut to the dimensions of the top of the tank to use as a sealer. I've wrapped it in shrink wrap to hold the fumes in so that they can react to the organic compounds in the fingerprints. I've also got some other items here, some of which are going to be the items we're going to be fingerprinting today. A soda pop can, a cologne bottle, maybe another can that was found, but any number of things you could use in this process. They don't just have to be some sort of can or a small item like that. I'm going to be using for a heat source a candle warmer. I've also got some hot water in a bowl that's going to be used to create humidity. And then I've got a little container that I'm going to be dropping several drops of super glue in order to start the process. So let's show you how it's actually going to be done. Now, there are different methods that you can use in order to collect fingerprint evidence. You can actually, with some of these methods, use a lifting mechanism in order to actually take the print from the surface that you can use for analysis and further investigation. But you can also photograph the fingerprint evidence. When you photograph the fingerprint evidence, that is very useful in courtroom settings because those can be enhanced so that judges and juries can make better, informed decisions based on fingerprints that you provide in a courtroom setting. Now, you can use techniques that are of a physical form, an instrumental form, or even of a chemical form in order to make latent prints or hidden prints visible to the naked eye so that you can better collect them or photograph them. Physical forms are going to be actually applying fingerprint powders or enhancers to the prints that will make them more photogenic and allow you to be able to lift the prints from the surfaces. Instrumental forms, such as what you would use in impression prints, will allow you to be able to enhance the print so that you can better photograph the print, such as with the using a forensic light source on an impression print. Chemical means, however, actually takes chemical components and allows those components to chemically react with the print itself. But in order to do this, you have to understand a little bit of the basic knowledge about what comprises a fingerprint. We know that fingerprints come from our friction ridges. Locard's principle says that whenever we come into contact with something, we're going to leave evidence of our presence there. There are two types of substances that come out of our friction ridges whenever we contact a surface: liquid and solids. The liquids take the form of our sweat, which carries the solids from our body, the organic compounds that are present in our fingerprints. Sweat tends to evaporate though because it's primarily made of water. The organic compounds, they stay behind though, as like a residue in line with our friction ridges. Organic compounds take the form of amino acids, riboflavins, lactic acids, that sort of thing. Chemical means of collecting fingerprints are going to react with those organic compounds that are left behind. That's where we come to the different sorts of techniques we use from a chemical standpoint that we're going to be talking about today. You can use different chemical reagents, small particle reagents, in order to spray onto an area that you believe has latent prints, and those will actually react with the compounds in your fingerprints and allow them to be dyed a certain color, okay, or be made visible so that you can process them, photographic means or whatever. But you can also use gaseous chemicals in order to bring latent prints to life. Now, another one of the chemical means that we're going to talk about today is going to be that of cyanoacrylate fuming, otherwise known as common superglue fuming. Now, this is a method that was pioneered back in Japan in the late 1970s and later brought to the United States through the United States Army Criminal Investigation Division as well as the Bureau of Alcohol, Tobacco, and Firearms. What it's going to use is the actual chemical components that are present in our fingerprints and how they chemically react with the agents that are present in the superglue. So now I've got my tank set up. I want to explain a little bit about why I have certain things in the locations that I do in the tank. My hot water is in the center of the tank. That's going to be my source of humidity. It will combine with the chemical reagents, the gaseous reagents from the superglue, and adhere to the organic compounds in the fingerprints. I want it to be centrally located so that it spreads evenly throughout the tank, because the tank is going to be sealed, holding in the humidity and the gaseous state of the superglue. I have my warming plate in the corner with the container I will be putting my superglue in. The warming plate is already turned on. It's warming up the actual container for the superglue, so it speeds up that transfer of the superglue from its current state into the gaseous state. So I'm going to arrange the items in the tank in such a way that most of the gases are going to have easy access to them. Now, what I've also am going to do, I'm going to place a soda can from a hanging fixture that I've attached to my actual lid made of styrofoam, and I'll be placing that down on there. So it's actually going to be dangling right above the humidity source, and we'll see what kind of prints we get off of that as well. So we're ready to start the process now. I'm going to be adding my superglue, several drops. There doesn't have to be a lot, just enough to turn into a gaseous state. And I'm going to add that to the actual container at this time. Okay, now let's get started and watch the process work. Okay, it's been several minutes, so let's open this up and see exactly what kind of evidence we've been able to make visible today. Make sure, since you are using gaseous fumes, that you have a well-ventilated area, because when you take this off, there's going to be some residual fumes left over. Disconnect your heat source. That way you're not continuing to make fumes while you've got the container open. Once you've taken those precautions, it's good to go ahead and take the lid off and see what you've got. Now, one of the things to consider is that anytime we're collecting prints, it's very rare that you're going to get an actual complete print from either a finger, a digit from your hand, or one of your toes, or a palm print. Most of the time you're going to get partial prints, and sometimes you're going to have other irregularities or smudges in the prints, things like that, that keep you from being able to get an actual perfect print. So that's not something that's a realistic expectation when you're in the criminal investigation field. We're going to have a look at some of the items that we had. We had a cologne bottle, a soda can, and then a can. It could have been a fruit can or something that was used, one that like you buy from a grocery store. It's had the wrapper taken off of it. And we'll look and see the type of prints that were made visible and the benefits that each surface has as to being able to see those prints. Take, for instance, on the cologne bottle, which is black, which makes it really good background for revealing prints, because whenever the chemical reagents attach to the organic compounds in your prints, it's going to solidify in more of a white form. We can actually see some pretty good print resolution there. As for our soda can, a little bit more difficult because there's sporadic color throughout the soda can background on there, so you have to look a little harder in order to see the prints, but you can make out prints from just casual contact with the soda can. As for the actual food can, it had the wrapper taken off of it. Well, when they make these cans at the factories, they put adhesive on the cans in order to allow the wrapper to stick to the cans. The adhesive in this case has really been problematic in being able to actually find a print and make it visible on the can. There may be prints on there, but because of all the adhesive that's on the can, we're dealing with a substance that's also an adhesive, the cyanoacrylate ester. It's making it really difficult to get any good noticeable prints off of this can.